Hadoop 2.x SDFS architecture. As we know, Hadoop 2.x is federation architecture where there are independent states being managed independently by their leaders, where all the leaders work together to achieve a common goal of reading and writing files in SDFS. Now, this is similar to what we have in our democratic system, where all the states are managed by center, where the states have independent power, but still they are managed by the center to achieve a common goal of democratic leadership. Now, in this case, active name node is center one, all the other name nodes are the states, something similar to the states. Now, how do you elect the actual primary name node or active name node? Now the question is this. So let's say I have 4 data nodes, N1, N2, N3, N4. All are connected on a network. Now there is one node is primary one or active one. Now this is the cluster. You are the admin. You are putting this cluster. 4 name nodes you have put. How it will choose which should be the primary one talking to our data node clusters. These are the theoretical principles that you need to get clearly, as if you go in an interview, these are probably questions going to come, and if you don't get it right, I think you never get Hadoop. Okay, so how do you choose that? Which would be the primary name node? There is a heartbeat mechanism that eventually is implemented in order to ensure one of the name node will be the node. You have to find out which one is healthiest node, because the rule number 1 is, before we go to scalability, what is the problem we saw? As we saw with availability, right? The name node has to be available. So in order to available, we need to find out of these 4 machines, N1, N2, N3, N4, which can be available for a longer period of time. So we measure heartbeats from those machines at regular intervals by putting another machine which is going to be heartbeat manager. Now the job of heartbeat monitor here is keep receiving heartbeats from and put a count of 1 if it is received and 0 if it is not received. After certain amount of time, let's say if it receives 1001 from node 1 N1, and if it is received 111 from node N2 and it receives 1011 from N3 and 100 from N4. Now, which is the healthiest machine out of N1, N2, N3, N4? Now, I can say N2 is healthiest machine, right? So, that's how the monitor chooses the healthy machine. At any point in time, the maximum number of heartbeats will be the one that will serve as active node, and in order to have a fair share, because this one if goes down, then what happens? That means all machines healthy, just choose one, right? But the problem is you go to choose healthy machine, if everything is healthy, then it is choose one. Just take an example, what if all the batsmen in India team score centuries and you have to choose a captain? Let's say you are the coach and you have to choose captain of India team, and you got all the people in the team are batsmen. What would you do? You choose one? You will not put your logic mind too much in it, because you just need a captain. So if all the machines are healthy, you can blindly choose 1 out of 4. You go and choose the healthy one. Okay? But again you are dependent on the heartbeat monitor to elect this guy. What if the heartbeat monitor itself is a problem? Or what if probably the machine N1 is good, but the link between the heartbeat monitor is not working? Let me show you again using the diagram. I have 3 nodes N1, N2, N3, and I have heartbeat monitor. So what if N1 is fine but the link is problem? So this could be the wrong value, If my N1 is giving 111, but the monitor is showing 1001. So in order to achieve better prospects or increase the probability of choosing in terms of federation architecture is by having voting mechanism combined with the heartbeats. That is coming in the system here. So by voting, there are uneven or odd number of machines will be sitting over the name nodes and will listen for the heartbeats from all the nodes. Everybody will be having their bitmap of heartbeat received or not. And at any point of time, the majority of bitmaps from these nodes will be designated as the active name node. Now these voting nodes in the system are called journal nodes. So the journal nodes are the nodes that serve the voting mechanism to elect an active name node with heartbeat receives at periodic intervals in time. So the journal nodes are the nodes that serve the voting mechanism to elect an active name node with heartbeat receives at periodic intervals in time. Now we are good with SDFS architecture from master-slave to federations, and the two problems are sorted out. One was the problem of availability and other was the problem of scalability, horizontal scalability. These are the data nodes we have and these are the name nodes we have. Name node connected to the data nodes and these are the journal nodes. Journal nodes are connected to the name nodes and we have the secondary name node. Client resides outside of the SDFS. Ideally, you don't need the secondary name node because the cluster here itself supported. But before we went to this scalability, we also talked about availability, right? So in order to ensure the availability is higher, we still maintain the secondary name node with hot standby. So it's part of architecture. But in Hadoop 2.x, it's optional. This is all about the Hadoop 2.x SDFS architecture. There are multiple name nodes available, so availability is ensured here. Okay,